Hi everyone, Assalamualaikum. In this video, we are going to continue with examples under volume by shell. Now we look at example 2 from previous semester papers. The shaded region in figure below shows the region R bounded by the curve y equals to x cubed and y equals to 2x plus 4 and the y-axis. By using shell method, find the volume of the solid when the shaded region is rotated about the y-axis, right? Alright, from the given region here, okay, this is curve y equals to x cubed, okay. This is the line y equals to 2x plus 4, okay. This is region R, right? And then from the given question, the axis of rotation is y-axis here, okay? And y-axis means line x equals to 0. So this is our axis of rotation, okay? Alright, using shell method, okay, if the axis of rotation is a vertical line here, okay, so we need to integrate with respect to x, okay. And when we integrate with respect to x, all mass in terms of variable x, including lower and upper limit, okay, we use the values on x-axis, okay. And under shell method, we use formula 2 pi here in front, okay, and then times radius times height, right? Alright, after rotation, we get this diagram, okay? Alright, from this diagram, this is the cross section, okay? There is a gap between the shaded region and the axis of rotation here, okay? This is the shaded region and this is axis of rotation, okay? We have gap here, okay? So, after rotation, the diagram will have hollow like this, okay? Here is hollow, okay? But this is from outside, okay? After we use cross-section diagram here, okay, then we can see the hollow here, okay? Alright, from volume by shell, we need to find the radius and height, okay? Radius equals to the distance between the shaded region to the axis of rotation, okay? This is the original shaded region, okay? And this is axis of rotation. So this is our radius, okay? The distance between the shaded region and the axis of rotation, alright? Alright, how to find radius using shell method, okay? Alright, from the original shaded region here, okay, and axis of rotation on the left side and the shaded region on the right side, okay. Let's say from axis of rotation here, okay, which is line x equals to 0, okay. Let's say we move to right hand side, okay. We move x here to right hand side, so we get 0 equals to negative x. Or we just leave x on the left hand side, okay. So we still get this, okay, x equals to 0, okay. Alright, from axis of rotation here, since the axis of rotation on the left side, when we compare to the shaded region, so our radius, we just keep the equation to left hand side, okay. So this is our radius, okay, not this one, okay, because the axis of rotation, we refer from the axis of rotation, okay, the axis of rotation on the left side, Okay, so we bring the equation on the left. Okay, right, so we can write radius equals to x. Okay, from here, our radius is in terms of variable x. This is a clue that we need to integrate with respect to x. Okay, because our radius now is in terms of variable x. Alright, when we use shell method. Okay, but under washer method, okay, when the axis of rotation is vertical line, we need to integrate with respect to y, not with respect to x. Okay, it's different. Okay, under washer method, we no need to find height, but we have outer radius squared and then minus inner radius squared. Okay, in shell method, okay, if axis of rotation is vertical line, we need to integrate with respect to x, and then we need to find radius and height. Alright? Alright, after we find the radius, then we need to find the height. Okay? Okay, from here, from the cross section of this diagram, this is the height. Okay? Right, the height equals to top minus bottom. Okay. Alright. So from here, if we integrate with respect to x, so the formula for height under volume by shell equals to top function minus bottom function. Okay. So from here, so we can replace top equals to 2x plus 4. From here, this is the top function. And then minus bottom. Okay, we can replace bottom by x cubed, this curve. Okay, so we get this. Okay, x cubed for bottom function. Alright, and after that, we simplify, so we get 2x plus 4 minus x cubed. Okay, so this is our height and radius. Right? From the previous slide, we find radius equals to x and height equals to 2x plus 4 minus x cubed. Okay. Alright, we recall back the formula under shell method. Okay. After we find radius and height, then we can set up the formula. Okay. For volume. Okay. Alright, so we have volume by shell equals to 2 pi. Okay, and then we integrate radius times height. Okay, and then to determine whether we need to integrate with respect to x or with respect to y, we can check the axis of rotation. Okay, so from this question, our axis of rotation is vertical line. Okay, under shell method, if the axis of rotation is vertical line, so we need to integrate with respect to x. Alright? And when we integrate with respect to x, we need to use lower limit and upper limit on the x-axis. Okay, this is the value on the x-axis. Okay, this is the original shaded region. Okay, so we integrate from the left to the right. Okay. This is the values on x-axis. Okay. Alright, then we replace radius, okay, equals to x. We replace here, okay, and height equals to 2x plus 4 minus x cubed, okay. Alright, at this point, we done set up the formula under volume by shell, okay. Means we done substitute the radius, the height, and the lower and upper limit. Okay. Alright, so from here, we need to expand and simplify. Okay. But before that, we can double check. Okay. All of these function in terms of variable x. Okay. Because the axis of rotation is vertical line under volume by shell. Okay. Alright, we recall back. Under shell method, if the axis of rotation is parallel to y-axis, means it's a vertical line. All term must in terms of variable x, okay, including lower limit and upper limit, must the values on x-axis, right? Right, so after we get all in terms of variable x, then we can integrate. Before that, we need to expand and simplify first. Okay, so we expand one by one. Then we get 2 pi integrate from 0 to 2, 2x squared plus 4x minus x to the power of 4 dx. Okay, then from here, we can integrate with respect to x one by one because in between is sum and difference. Okay, so we need to integrate using sum and difference rule. So after we integrate, we still have constant in front here. Then we integrate 2x squared. We still have constant 2. We integrate x squared using power rule. So we get x cubed over 3. And then plus, we still have constant 4 here. And then we integrate x with respect to x. Okay, so we get x squared over 2. And over 2 here, we can simplify with 4 here. So we get 2 and then x squared. And then minus, when we integrate x to the power of 4 using power rule, so we get x to the power of 5 over 5. Okay, this is definite integral. So no plus c, but we need to put square bracket with lower limit and upper limit. Alright? And after that, we substitute upper limit into variable x. And then in between must minus. Okay, then we substitute the values of lower limit into variable x. Okay, when we substitute 0 into variable x here, we get 0. Okay, alright. Then we simplify here, so we get this. And the final answer, volume by shell equals to 208 over 15 pi units cubed. Alright. We can check the final answer using Symbolab. Okay. From here, after we set up the formula, after we substitute the radius and the height and the lower and upper limit here, so we can use Symbolab to calculate. Okay. So from here, we have 2 pi and then we integrate from 0 to 2 and then x, 2x plus 4 minus x cubed dx. Okay. Alright, so from here, we just press enter. Then we get the final answer 208 pi over 15. Okay, here. Okay. Alright, from the final answer here, okay, we can see that the volume here is positive. Okay, because volume and area always positive value. Okay, if we get negative value, we need to double check the formula that we set up, and then maybe we make mistake when we integrate or when we substitute the lower and upper limit. Or maybe we make mistake when we find the radius or height. Okay. Alright, so from the final answer here, we just leave the answer in fraction and pi. Okay, because it is more accurate compared to decimal. Alright. Got it? So this is the solution. Okay. But before that, we need to find the radius and the height. Okay, in the previous slide. Okay. Coming up next, more examples for volume by shell. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.